Okay, we're about to get into the absolutely wild story of a code that was supposed to be unbreakable until, well, it wasn't. This is a true cryptographic rise and fall.
So for years, you've got some of the smartest people on the planet working on this, a kind of digital fortress. And their whole mission? To protect everything, our entire digital lives from this huge threat on the horizon, quantum computers. I mean, this thing was supposed to be the future of our security.
And then, August 2022, that digital fortress they spent years building, it didn't just get a crack, it came crumbling down, just like that. The unbreakable code was completely broken. And here's the part that's just mind-blowing. This thing wasn't taken down by some futuristic quantum supercomputer from a sci-fi movie. Nope, it was cracked in about an hour on a single, normal, off-the-shelf laptop. Think about that for a second. A stunning, total collapse. So you gotta be asking, how on earth did this happen? Well, to really get the drama of it all, we first need to back up a little and talk about this giant threat that's hanging over all of our current digital security. And that brings us to this idea: post-quantum cryptography, or PQC for short. Look, this isn't just some small software update. We're talking about a completely new generation of codes. They're being built from the ground up to survive in a world where quantum computers are a real thing.
So here's the deal, right? The encryption that protects basically everything today, your bank info, your messages, all of it, it relies on math problems that are just way too hard for our current computers to solve. But for a powerful quantum computer, using something called Shor's algorithm, it's like a hot knife through butter. Trivial. And that's why this is such a frantic race against time. We need to find a replacement before those machines get here.
So in this race to find our new digital champion, one candidate really stood out. It was super promising, really elegant, and it was based on this beautiful but, wow, incredibly complex corner of mathematics.
And that idea was called Super Singular Isogeny Diffie-Hellman. Yeah, it's a mouthful, so we'll just say SIDH. And it took off like a rocket. You can see on this timeline, it started as this slow kind of theoretical idea, but then it just got faster and faster until it became the super fast contender, eventually named Psych. It was a finalist, you guys, a finalist to become the world's next crypto standard. So, what was the big deal with SIDE? What made it so cool? Well, at its core, it was all about creating a secret map. The whole idea was you could navigate a secret pathway that's called an isogeny between these two really complex mathematical landscapes. These things are called elliptic curves. To really wrap your head around that, let's use a classic analogy you might have heard before: mixing paint. You know, Alice and Bob create this shared secret color, and some eavesdropper who only sees the colors they're swapping in public just can't figure it out. It's the classic Diffie-Hellman key exchange. Okay, so SID uses that exact same logic, but with this really cool mathematical twist. So instead of paint colors, Alice and Bob start on the same landscape. That's our elliptic curve. Then they each take their own secret path, the isogeny, to a brand new landscape. And by sharing just a little bit of public info about where they ended up, they can both figure out a shared secret landscape, a secret key that an eavesdropper just can't get to.
I mean, it sounds perfect, right? The public info they swapped was never, ever supposed to give away their secret routes. But, and this is a big but, it turns out there was a fatal flaw, and it was hiding in plain sight the entire time.
See, this public information, these little guideposts Alice and Bob are exchanging, they were absolutely essential to make the whole thing work. But they came with this really dangerous side effect, something nobody saw coming.
That extra public data, it basically leaked information. It left behind these hidden clues, almost like a mathematical fingerprint at a crime scene. It created this hidden algebraic structure that, well, an attacker could use to follow their tracks and trace their secret steps all the way back.
And this is where our little detective story hits its climax. Because once that hidden flaw was known, it was only a matter of time. A couple of researchers found the key to unlock the whole puzzle, and they turned this theoretical weakness into a devastatingly simple, practical attack.
So you have these two researchers, Wouter Kastrick and Thomas DeCreux, and they had this absolutely brilliant idea. They basically dusted off this old, kind of obscure math theorem from 1997, and it acted like a Rosetta Stone. It let them take those public fingerprints and translate them directly into the secret key.
Yeah, this really sums up the genius of the attack. That extra public info wasn't just a clue, it was a blueprint. It gave the attackers everything they needed to build a mathematical bridge, completely bypassing all the fancy complex security and just walking straight to the secret key.
Just game over.
So Psych is dead, completely broken. You might be thinking, wow, what a disaster for cryptography. But not really. Actually, in the world of open, peer-reviewed science, this is exactly what progress is supposed to look like.
Think about it. The whole system worked perfectly. This huge critical flaw was found by researchers, not by bad guys trying to steal your data. It was found before it was rolled out everywhere and could cause real damage. So the community learned a massive lesson, Psych got pulled from the running, and now the hunt for a secure code continues, but everyone is a whole lot wiser.
And it just leaves you with this really cool thought, doesn't it? This whole story is just the latest chapter in an ancient game. For as long as we've had secrets, we've built codes to protect them. And for as long as we've built codes, there have been brilliant people trying to break them. It's this constant cat and mouse game that, honestly, never ever ends.